In chapter 12, 12.3, we are solving more advanced equations from chapter 4, which was the basic equations. What we want to do is move like terms together. So get all the unknown terms on one side, get all the constant terms on the other side. So it's 5r minus 2r equals 6 plus 4. Then we want to combine the like terms. 5r take away 2r is 3r. 6 plus 4 is 10. Finally, we divide by the coefficient of the unknown, which is in this case is 3. So the answer is 10/3. The next problem is going to involve distribution. Okay, we see that we have a distribution here. So it's 4n minus 3n plus 27. Watch that distribution. Equals 2 plus 2n. Simplify on the left-hand side. 4n take away 3n is n. Plus 27 is 2 plus 2n. Move the n terms to one side, the left. So n minus 2n. Move the constants to the right. 2 minus 27. That gives me a value of minus n equals minus 25. That's not the answer. We're looking for what is plus n. Plus n is equal to 25. Here we have a little bit more involved problem. It's a parentheses within a bracket. So we would like to distribute within the bracket first, right over here. So it's 2 bracket 3z minus 10z plus 15 close bracket equals 4z minus 6. Simplify within the bracket. So 3z minus 10z is minus 7z. Add 15. Next step is to distribute the 2. So we get minus 14z plus 30 is equal to 4z minus 6. Move like terms together. This time I want to move the unknown term to the right. And the reason I'm doing that is I like to work with positive coefficients. I get into less trouble if I have positive coefficients. So I'm moving minus 14z to the right, so it's positive. I'm moving the minus 6 to the left. It is also becomes positive. Combine like terms, I get 36 equals 18z. Dividing both sides by the coefficient 18, I'm going to get z is equal to 2. Notice how I laid out complete steps one at a time. I don't skip any steps. I don't try to rush the problem, and that helps me be more successful. Finally, let's look at an application. The office manager of an election campaign office needs to print 5,000 postcards. Suppose that it costs 2 cents to print a large postcard and 1 cent to print a small postcard. If we have a total of $86 for printing, how many of each type of postcard can be printed? Notice it defines X as the number of large postcards, which I've written down over here. So therefore, how many small postcards do we have? Well, if the total number of cards is 5,000 and X is the number of large, then 5,000 minus X must be the quantity of the small cards. Now we need to write an equation that represents cost. The total cost of mailing both types of cards is equal to the cost of mailing the large cards plus the cost of mailing the small cards. So $86 is the total cost that we have available. It's 2 cents per large card, so 0.02 times X. It's 1 cent for each small card, so it's 0.01 parentheses 5,000 minus X. Now, what I've done, I don't like working with decimals. I'm giving you some hints. I don't like working with decimals, so I want to remove the decimals first. I notice I have 2 decimal places. To get rid of the 2 decimal places, I'm going to multiply each term by 100. 100 times 86 is 8600. 100 times 0.02x is 2x. It's 100 times this term, not 100 times each piece. So 100 times 0.01 is 1 times the remaining part, 5,000 minus x, which then simplifies to 2x plus 5,000 minus x. Combine the like terms on the right, that gives me x. I move the 5,000 to the left, that gives me 3,600. That is the quantity of the large cards. The quantity of the small cards is the total number of cards, 5,000, minus 3,600 large, leaves me with 1,400 small cards.